Hello. So today we're going to look at 2.2 notes, and they talk about subsets. So a subset, we're going to define a subset first. So set A is a subset of B denoted as, this is how you denote it, if and only if every element in set A is also an element in set B. So every single element in the subset has to be an element in the set. So let's look at, we have set C and set D, set A and set B here, and let's look at the examples. So actually I'm gonna zoom out this a little bit so that we can see the whole page. Is that all I can do? Here we go. That should be enough. Okay, so first in example 1, we're going to identify the elements in each set. And we are using the roster method. So the roster method, remember, is the one where you have the braces and you list all the elements. So if we look at set C, so set C is this set right here. So everything inside this oval is part of set C. So I'm going to start here. 2, 6, 10, and 14. And these elements are inside set C as well. So they are part of set C. 12, 4, and 8. And as you notice, the elements, the numbers, are basically in no order. I just listed them in the order that I got them from here. So that is our set C. Now, our set D is going to be this one here. So the elements in set D are 12, 4, and 8. And that's it. Set A. So set A is this one here, this left circle. So the elements in set A are 1, 2, 4, 3, and 5. And again, do not forget to use those braces when you're writing a set. That tells us that it is actually a set. Okay, next one, set B. So set B would be everything inside this circle here. 3, 4, 5, and 6. So those are the elements in set B. Okay, so now we've identified the elements in each set. Next, we're going to go ahead and see if it is true or false. So remember, this is a subset. So we're going to see if set D is a subset of set C. So in order for set D to be a subset of set C, every element in set D is also an element in set C. So if we look at this diagram here, we have set D here inside set C. So all of the elements in set D, 4, 8, and 12, are also inside set C. So this one is true. Now, we could also compare the roster methods that we wrote. And see that we have 12, 4, and 8 in D, and we have 12, 4, and 8 in C. So D is a subset of C. Next one, is set C a subset of set C? Well, if we think about, are all the elements of set C also elements in set C? Yes, they are, because it's this whole big circle here. So set C is a subset of set C. Next, we've switched around. So now it's asking if set C is a subset of set D. Again, remember that every element in set C has to be in set D in order for this to be true. Well, set C is the bigger one, and there's 2, 4, 10, and 14, those elements outside of set D. So this is not true. So that is false. So you've got to be careful which way they are. Okay, next, D. Next one is set A a subset of set B? So set A is this one that we shaded pink, and set B is the one that we shaded blue. Well, if we compare those, we notice that set A has the elements 1 and 2 that are outside of set B. So it is not a subset because these two don't belong in set B. Okay, next we're going to flip these around. So is set B a subset of set A? Set B is this one here, a subset of set A. Well, we have that element 6 that is outside of set A. So this is not true. It's false. Okay, next. Is set B a subset of set B? Well, if we take set B, it of course has all the elements that set B has. So this has to be true. So next question. Can a set be a subset of itself? Well, we have here B and F that answer our question, and yes, it can. Number 4, which Venn diagram would represent a subset relationship? 2 overlapping circles or 2 circles where one fits completely into the other? So if we look at these where we had false and where we had true, so these are our overlapping circles, and this is one where or one fits completely into the other. So we answered on number 2 that the set A or set B can't be subsets of each other, where here set D can be a subset of set C. So it's the 2 circles where one fits completely into the other that represents a subset relationship. So it's this with the set C and set D. Okay, let's move on to page number 2. Okay, I'm gonna zoom again a little bit so that it's, here we go. So a note, this here is red. A is not a subset of B. So notice that line that is drawn across the symbol for a subset. When we have that, it is not. So now on number 5, we're going to fill in whether it is a subset or it is not a subset. So right now, we only have the listings of the elements. We don't have those Venn diagrams that we had on the previous one where we had those circles and ovals. So now we're going to have to look at these elements from here. You could always draw the Venn diagrams and put them in. but we're going to just look at it here. So A, we have C and a D. So is set C a subset of D? If we look at the set C elements 2, 4, 6, and 8, D has 2, 4, 6, and 8. So yes, C is a subset of set D because all the elements in C are in D as well. Okay, next, B. Is C a subset of E? C a subset of E. So C is 2, 4, 6, 8. E is 2, 4, 6. Well, E does not have 8, so it is not a subset. What if we did this the other way around? Is E a subset of C? Well, if we look at E, we have 2, 4, and 6. Those are all elements of C, so that is a subset. So set E is a subset of set C. So see how it changes when we flip them around, which one is the subset and which one is the set? It might not. It might be that both of them are not subsets. But in this case, E is a subset of C, set C. Okay, let's go on to C. So is set C a subset of set F? So set C has 2, 4, 6, and 8. F has 0, 2, 4, and 6. Well, they have 3 elements that are the same, but it is still not a subset because there's an 8 and a 0. And now if we flip this around, so if we do, is F a subset of C? Well, F has 0, 2, 4, and 6, and C has 2, 4, 6, and 8. Again, F has the 0 that C doesn't have, so this is not a subset. So like I said, even if we flip, it doesn't necessarily mean that they are subsets, even though in this case it is. Okay, let's look at D. So we have C and we have G. 2, 4, 6, and 8. 2, 6, 8, and 4. Okay, we have the exact same elements, but not in the same order. The order does not matter since we have them in, or have the same elements here. C is a subset of G. And since we have the exact same elements, we could also write that G is a subset of C. Because these are equal. Remember, equal meaning that they have the exact same elements and the same amount of elements. Okay, let's move on to proper subsets. So set A is a proper subset of set B, denoted as, so this looks very familiar. The only thing different from subset is that it doesn't have that line underneath. So is a proper subset if all elements in set A are in set B. All elements are in set A are in set B. So this is the same as a subset. Now the difference is this one here. Sets A and B are not equal. So they cannot be equal. Okay, number 6. Consider the sets below. We have set A, set B, set C, and set D. So we're going to look at set B, and it's asking, is A a subset of set B? Well, A has elements 1, 2, and 3. So does B. 1, 2, and 3. And then B also has 4. But that does not matter because all the elements in A are in B. So yes, it is a subset. So next we're going to ask, is A a proper subset? Well, set A is a proper subset if sets A and B are not equal. If we look at A and B, they are not equal. B has 4 elements where A has 3. So this is not a proper subset. Or it is a proper subset. I'm sorry. It is a proper subset because we have all the elements that are in A are in B, and then they are not equal. Okay, next one. Is A a subset of set C? A and C. If we look at these two, we have the exact same elements. So yes, it is a subset. Well, it cannot be a proper subset because they are equal. We have the exact same elements, the exact same amount, so they are equal. It cannot be a proper subset in that case. Okay, next is set A a subset of set D? 1, 2, 3, 2, 3, 4. Well, we're missing 1 in set D, so no, it is not. And proper subset, all elements in set A are in set B? No. Not all elements of set A are in set D, so it is not a proper subset. So number 7, when is a subset not a proper subset? It is not a proper subset when the sets are equal. So if everything else is the same, but when the sets are not equal, it is not a proper subset. When the sets are not, when the sets are not equal, it is a proper subset. I'm sorry. When the sets are not equal, it is a proper subset. So if the sets are equal, it is not a proper subset. That's it. Okay, next one, number 8. For a non-empty set H, can we say that set H is a proper subset of set H? That is, can a set be a proper subset of itself? Well, the answer is no. It is no because sets can't be equal. Remember here, sets A and B, sets A and B are not equal. So we're talking about the same set over here. It cannot be. Okay, let's move on to the next page. We are going to be talking about the empty set. And now this page might have you spinning afterwards, but don't freak out. This just kind of explains the empty set. It doesn't mean that you have to, memorize every single thing on here. You just need to kind of understand what the empty set means. So the empty set. Is the empty set a subset of any non-empty subset? Like this. Yes, it always is. So do not forget when we start listing subsets that you have to list the empty set as a subset as well. Okay, so let's look at some background. Let's revisit the definition of subset and discuss another perspective. So according to the definition of subset, if every element of A is in B, then set A is a subset of set B. We can see that this is the case for the sets below. The sets A and B below, these sets here. We can see that set A below has an element 5 that is not in B, or we could say that set A contains an extra element. So in this case, set A is not a subset of set B. In this case, it is a subset. In this case, it is not. Another way to say that every element of A is also in B is to say that A contains no elements that are not in B. A has no extra elements. So we could say if A contains no elements that are not in B, A has no extras, then set A is a subset of set B. Does this work for our first example? Set A is 1, 2, and set B is 1, 2, 3, 4. So if A contains no elements that are not in B, then set A is a subset of set B. So if we look at what set A contains, it contains 1 and 2. If A contains no elements that are not in B, there are no elements in A that are not in B because we have the 1 and 2 in both. So it does work. Now consider the empty set. Is there an element of the empty set that is not in B? Nope, there is not. Next, is the empty set a subset of B where B is a non-empty set? True or false? This one is true. There is always the empty set that is going to be a subset of the other set. In this case, it's B, and B is a non-empty set. Okay, let's move on to the next page. How could we determine how many subsets a given set has based on its cardinal number? Determine the cardinal number of each set, list out each of its subsets, and remember that a set is a subset of itself. So, cardinal number is the number of elements. So this set has 0 elements. So the cardinal number of the set is 0. Specific subsets, that's going to be your empty set. That's it. It doesn't have any others. Okay, this next one, cardinal number of this set. Well, that's going to be 1 because there's 1 element in here. Now, specific subsets. Yes, the element A is a specific subset, but also we need the empty set in it as well. Next, we have A and B. Our cardinal number is as many as the elements we have, so this is 2. And now, when we start writing the subsets, we don't forget your empty set. Then we're going to have a subset of A, a subset of B, and a subset of both A and B. Because of course this is a subset of this also. Okay, next one. The cardinal number of the set, 1, 2, 3 elements, so this means that the cardinal number is 3. Now, we start with our empty set again. We start with our single A, B, and C. Next, we're going to combine these elements. So we get AB, BC. So we have AB, BC, and then we need AC. And the last one is A, B, and C. So it actually has 3 elements in it. Okay, next line. We have 1, 2, 3, 4 elements, so our cardinal number of the set is 4. Now we're going to look at our specific subsets again. We have the empty set, And then we're going to list the subsets where we only have one of these elements. So A, and again, do not forget those braces. So there are the single element subsets. Now, next we're going to list the ones with the two elements in each. And that's going to be AB, BC, and AC. Next, we're going to list the ones with the three elements. And that's going to be A, B, C, actually, you know what? I messed up. Ha ha. I'm missing. If you look at this, we have a D here as well, not just A, B, and C. So let's actually restart this. I apologize. Let's actually go ahead and restart this and go over here. I'm going to take a piece of blank paper so that I actually have enough room and I'm just not scribbling in that tiny space. So our set is A, B, C, and D. So our subsets, first we have our empty set like we talked about. Then we have our set with the element A, element B, element C, and element D. Next, we're going to start writing down all the subsets that have two elements in them. So before we do that, what I'm going to actually do to make this a little bit easier, hopefully, is I'm going to write these elements to here. So I have A, B, C, and D, and then I have A, B, C, and D. Now, I'm going to start combining these. So I have AB, that's one of the subsets. I have AC, and I have AD. Okay, next I'm going to pull B. I already have AB, so I don't need to write that down. It is already here. BC is here. And then BD. Okay, next we have C. CA is already here. CB is here. CD is not on here. Now, if we start drawing the lines from D, we get DA, that is already here. DB is there, and DC, which is here. So we have all those. Okay, so those are with the two elements. Now we're going to look at with three elements. So I'm going to do A, B, C, and D, A, B, C, and D, A, B, C, and D. So we're going to start with A, B, and C. And notice, again, one thing I think I haven't mentioned, we are not listing a double, or we're not listing the same, where each element is different in these cases. Because basically we only have those elements once. We don't have them twice, or three times, or four times. We only have them once. The reason why I'm writing these here it looks like it's going to be 3 times because it helps to visualize which ones we need. So now we have A, B, C. Next, we're going to do A, B, and D. So A, B, and D. Next, we're going to pull A, C, and B, which is here. A, C, and C means that we have double C. A, C, and D is not on here, so that's going to be right here. Okay, next one. What we're going to do with that is we've used A with everything already, so we're going to take B. So B, A, C is right here in a different order. B, C, A is right here. B, C, C, no, not B. B, C, C, D is the one that we're missing. B, C, D. Okay, all these others with C and D we have used already in here. Double check and make sure, but this is how we're going to leave it. Except we need one more subset. And that subset is going to be the set itself. So A, B, C, and D. So these are all the subsets for this one here. All of these. Okay, let's move on to the next one. And now we're going to use this table that we just filled with this next question. So number 9, summarize your results to discover a pattern between the cardinal number of the set and the number of subsets. So if we look at the cardinal numbers, we have 0, 1, 2, 3, 4, and then it's an n. Now we need to figure out the number of subsets. So we have our subsets here for the empty set is 1. For this one, actually, let me write them here. So this is 1. The subsets for the cardinal number 1 is 2. The subsets for the cardinal number of 2 are 1, 2, 3, and 4. For cardinal number of 3, 1, 2, 3, 4, 5, 6, 7, 8. For 4, we need to take this paper here and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's 16 here. And then we need to figure out n, what n is. Okay, so let's see if we have anything that we could use. If you look at these, they're all divisible by 2, right? So actually what they are is they are multiples of 2. So if we take, for example, 4, well, 4 is 2 times 2. That is at the same time 2 to the power of 2. 8 would be 2 times 4, which is 2 times 2 times 2, which is 2 cubed. There's 1, 2, 3, so that goes in the exponential, or exponent, I mean. 4, 16 is 2 times 8, but it is also 2 times, so 8 is 2 times 2 times 2, so this is 2 times 2 times 2, which is 2 to the power of 4. That is 2 to the power of 4. So this would be 2 to the power of 4, 2 to the power of 3, 2 to the power of 2. 2 again, we don't write the exponent 1. So this is actually 2 to the power of 1. It's the same thing. We just don't write that one. But here, what about this last one? So if we're looking at the cardinal numbers are as exponents here. So we have 4, 3, 2, and 1. So this would mean that it's 2 to the power of 0. Well, if you put it in a calculator, you know that 2 to the power of 0 is 1. So these are all correct. Now, for a cardinal number of n, that is going to be 2 to the power of n. We don't know what the n is. It is an n. Okay, number 10. What kind of reasoning did you use? Did you prove your conclusion? Well, we used inductive reasoning here. And did we prove our conclusion? For inductive reasoning, we would need to do if we wanted to prove it false, we would need to do a counterexample. And right now, we don't have a counterexample. So yes, we did prove our conclusion. Okay, next one. Formula for the number of subsets. So that means this here, 2 to the power of n. How many subsets of a given set are not proper subsets? So if you remember, where is that page where we talked about the proper subset? Here it is. So proper subset is all elements in set A are in set B. So that is the same for a regular subset, and sets A and B are not equal. So that means that there's one subset that is like this. So here's how many subsets of a given set are not proper subsets. That's 1. Next, how could you adjust the formula to determine how many proper subsets there are? So the formula for the number of proper subsets is 2 to the power of n minus 1. Oops, I'm sorry. 2 to the power of n minus 1. There you go. Okay, number 11. Use your formulas to determine the number of subsets and proper subsets for each of the set below. So set S is X is such that X is a day of the week. So we have the days of the week, which means that we have 7 days of the week. So that means that all of these 7 days of the week are also 7 elements in that subset. So subsets were 2 to the power of n, 2 to the power of 7, and then please do this on your calculator. 2 to the power of 7 is 128. Now it's asking for subsets and proper subsets. So the proper subset we get by subtracting. 128 minus 1 is 127. Okay, let's move on to the next one. So this one, t equals, or set t equals, x is such that is a natural number, and 2 is less than or equal to x is less than or equal to 6. This is a 6. So we're going to write the elements and count how many there are. So less than or equal to, so 2 is counted, 2, 3, 4, 5, and 6. And that's where it ends, because there is an equal sign, so 2 and 6 belong there, but it doesn't go any farther. So how many are there? How many elements? 1, 2, 3, 4, 5. There are 5 elements here. So that means that when we start calculating our subsets, it is 2 to the power of 5. which if you put it in a calculator is 32. Now proper subsets. What we do is we subtract that. So it would be 2 to the power of 5 minus 1. We already know that this is 32 minus 1, so it is 31. So those are the proper subsets, and these are the subsets. Let me grab my calculator, and I'll show you how to put it in the calculator. So the calculator that I like to use is the TI-30X. This you can purchase at Walmart, Amazon. I think that I haven't checked lately, but it's about $50. These are the calculators that, for example, our testing center uses on campus. But anyways, this is the one that I'm going to be showing how to use. So we're putting in the subset 2 to the power of 7. So we're going to put 2, and then we're going to use this. This means exponent. So you see that that same symbol went up there. Then I'm going to type 7 and press equal, and I get 128. Same thing for here. I'm going to clear first. 2 to the power of 5 equals 32. So the one underneath it is the x squared. So if you're just needing an x squared, or let me do, for example, 5 squared, it'll be 25. So you don't have to type in the 2. If we do 5 to the power of 2, we get 25 as well. So that's where that exponent is. Okay, well, that's it for today. And like I've said before, make sure that if you have any questions, please do not hesitate to ask them from me. I will be more than happy to answer. Bye.